let's discuss Python data types. I'm on the Linux machine. First, I'll see where I am, see where my files are, make a folder or directory called Python data types. Oh, by the way, what I did there, you can, if you're typing a command and you're going to refer to like a file or a directory, you can start typing it and then hit tab, and it will finish as much as it can. If it stops before it finishes the whole thing, you can hit tab again. So hit tab twice rapidly, and you'll see all the ways that it can finish. And so you have to give it a little more information, like the D tab, and it will finish it. So that can be pretty convenient. This is the new directory, so there's no files. So let's do nano datatypes.py. So I'm not going to import anything or whatever. This is just standard Python data types. So the set of numbers that we have access to include int and float. Integer data types are like I is 0, print I. I is an integer. And to indicate that, I'm going to use a comment. So comments in Python are just messages to yourself. They're like notes inside of your code. It's not code. It's just going to be ignored when Python executes it. So I'll put a comment here that I is an integer. All right. We also have floats. So f is a float. F is 3.3, for example. And if you print f, you'll see that it has the decimal point. Let's look at that. So there's the 3.3. Not too exciting yet, but what we can do is we can convert one type to another. So we can say f int is the integer version of f. So up here is a command called int, actually a function called int inside parentheses. So pretty much anything with parentheses is a function. Inside the parentheses, you give it the argument or the data. So this converts f to an integer. And the way it does that is it just chops off the 0.3. You can see this here. It's just 3 now because int chops off the 0.3. Now, I don't think it rounds. So if you have 3.9, I don't think it's going to round up to 4. Yeah, it's just 3. So converting a float to an int chops off the decimal point. You can convert an int to a float. I don't think we're going to really see the difference, but here is an int converted to a float. We can say I float, I guess, float version of I. And it'll probably just look like 0 again, but technically it's a float by that point. So there's an int function, there's a float function to convert one way to the other. Oh, 0.0. All right, so it is clear that it converted to a float. All right, now strings use quotes. Strings are words. So name is Josh. We'll say first name and last name is Ekra, and you can print first name, print last name. Obviously, you'll just see those words. Not a big deal, but these are strings. They're obviously not numbers. You can convert a string to a number if it is a string that has a number inside. So we can convert a string to a number. So we can say like x is we'll say j is the int version of this number. Or x is the float version of this number. So not only could you use int and float functions to convert a number to a different kind of number, you can convert a string to an integer or a float. Here's that running, so everything's working correctly. Now suppose you try to convert something to an int or a float, and it's a poorly formatted string, like it's a string that doesn't have a number in it. So we'll try y is float of my last name. So we'll use the variable last name to feed in instead of using quotes again. Then we'll print y. So it gets to that line of code and then it fails. It does not know how to convert that word ekroth to a number. So it's simply gonna crash. And this most often happens when you do something like float of input. So we don't use that, we say input, enter a number. So we're gonna ask the user for a number and then try to convert it to a float. Now it just depends on what they type. If they type something bad, we have a problem. So if you type something good, it's fine. If you type something bad, it crashes. And there are ways to prevent that crash. It's called Trycatch. You can basically attempt to convert to a float, and if it fails, you can detect that and do something else, like ask for the number again, for example. But that's for later. The point here is just the conversion from a string to something like int or float could crash your program if you don't have a proper string. So I'm going to comment this out, and I'll say this might crash if the user enters a bad value. All right, so now we can just quickly talk about arithmetic. Obviously, you can do addition, subtraction, division, whatever. For integers, you can do the same thing with floats. You can even mix floats and integers, and you'll typically get a float as a result, and all the usual stuff. Strings have plus redefined as concatenation. So strings are slightly different because if you add two strings, obviously since they're strings, they're not going to add as numbers unless you've converted them, and then you don't have strings anymore, you have numbers. So if you have actual strings and you do plus, then it's going to stick them together. We call that concatenation. It's just putting one to, join together. So you could say full name is first name plus last name. So it sticks those two variables together, and you can see that here. See, it stuck the two together. If you want a space between them, you can do another plus with a space between the two things. So that's string concatenation. Now, you can actually multiply as well. It's repetition. So if we say line equals quote, we'll do minus sign times 20. It's a quick way of getting 20 little minus signs. And there they are printed. Right, so there is a multiply operation for string. It's obviously not numeric multiply. It's used for repeating something. So string concatenation and repeating strings are kind of special cases. Normal arithmetic works, plus, minus, divide, and so forth. And be careful about your conversions. Otherwise, everything acts pretty much as you would expect. Lastly, we have the Boolean data type, which are only the options true and false. And then we have none type. So we can say answer is true or answer 2 is false. Those are Boolean types. See how they're colored differently because Nano understands Python code just a tiny bit, so it'll color stuff based on certain phrases. And true, capital T true is how we say true in Boolean. If you say lowercase, it's going to crash because it means nothing. So you want to do capital. And Booleans, true false will be used later for if and else, but just understand that that's actually a separate data type. And then none type, none means it hasn't been defined yet. So sometimes you'll use none in an if. You'll say if this variable is none currently, then do such and such. So this is kind of, answer 3 could ultimately be an integer or a string or something, but at the moment it's a none, and that's like a special marker that nothing has ever been established for answer 3. That is the quick rundown of the basic data types in Python. We'll have separate video about data structures, which is like how you collect a bunch of data, like in a list, because there's a few ways to do that. But this is the fundamental collection of data types.